Welcome to Cisco TechBeat, the podcast that explores the people and stories behind what inspires the newest innovation. I'm your host, AB, and I'm thrilled to welcome our very own Tom Gillis, who is our SVP and GM of Infrastructure and Security Group at Cisco. Tom, welcome to Cisco TechBeat.
Thanks, AB. Good to see you.
Likewise. So I heard you describe AI as a tidal wave that's pretty much impacting every industry. What's Cisco's role in that? How are we evolving to handle this big change here?
Yeah, I think it's impossible to overstate the impact that AI is having on basic business processes and the way we work. And kind of the way I describe it is, with the release of ChatGPT 5.2, I'm now convinced that ChatGPT is both smarter and funnier than most of my friends. Right? So and maybe the bar is kind of low there. I don't know, but with all due respect to my friends, but clearly transformative, right? And so what's interesting about AI systems is that the computers that run these AI applications are going to look nothing like the computers that run a Kubernetes or VM-based application. Huh. They're massively parallel. And if you're like a computer science nerd like I am, it's the thing we've been chasing after for kind of a couple decades is what we call composable systems. So we're going to have this big giant grid of computing elements, a big giant grid of memory, a big giant grid of storage elements, and then you put them together to make a computer has the right shape to do the job that you need done.
Right.
The network becomes the substrate that you compose these systems on.
Right.
So in many ways, the Ethernet network, hopefully the Cisco network, plays the role that the PCI bus used to play in a server. It's the thing that stitches together the various components, the storage, the memory, the compute, and turns it into, an overall coherent system. And in the case of it, AI infrastructure, these are massively parallel, incredibly powerful systems. So the network is super duper fast and very, very performance sensitive.
Right. Okay. And now, of course, with AI, we have a huge security component that goes along with all this. So how is Cisco sort of evolving in terms of how we approach security within this new AI era?
Yeah, again, the shift that we have happening with these AI applications is fundamentally transforming the language of security, kind of the primitives that we use for security. So in a world without AI, an application is a very predictable thing. You click on a link, it's going to do a bunch of things, and you know exactly what they are.
Right.
Now introduce a model into that, and the application has reasoning. Right. And so, which means it's non-deterministic. You can ask it the same question twice. It'll give you two slightly different answers. To put security guardrails around a non-deterministic asset is a much harder problem than we had in the more predictable deterministic world. Right. And so something like a firewall needs to dramatically change. Right. And we would need to be able to look at the back and forth between either a user and a prompt, or more and more between an agent and an application, right, using MCP. We need to be able to look at that interaction and apply our own reasoning to say, does this look right?
Right.
Okay. So let me give you a real example of this. Is when a model learns something, it never forgets. That's one thing our listeners need to understand is that when your data goes into the model, it kind of gets absorbed in there, and you can't go back and delete it.
That's right.
Out of the database.
Right.
So when a model learns something, that data is gone. And it's out in the ether. So you want to be really careful about what data is exposed to the model. Now, you can tell the model, look, I'm going to give you Tom's bank account number.
Right.
But you tell it explicitly, do not reveal Tom's bank account number. The model will say, okay, good, I'm not going to reveal his bank account number. But if you remember the game when we were kids, 20 questions?
Yeah, absolutely.
I got a secret. You've got 20 questions you can ask, right? So you can almost always get the secret in way less than 20 questions.
Right.
That's what happens in AI applications, in that I could ask the application, hey, what's Tom's bank account number? The application will say, oh, I'm not supposed to tell you that. I can't give it to you. And be like, okay, no problem. I'm going to ask a different question. Is Tom an employee of Cisco? Yes, he is. Is he on direct deposit? Yes, he is. Is there a number associated with his direct deposit? Of course there is. Here's the number.
Right.
Right? So static rules can't solve the 20 questions problem. But at Cisco, we've been investing in these specific security models that we manifest what we call AI defense, that allows our infrastructure to be able to interpret and understand AI. So we're putting AI awareness into our network security, which is a really, really, I think, a big step forward.
Absolutely. And I know you mentioned, things are so much more unpredictable now. And of course, if you look back, when you were looking ahead at what AI would do, you probably thought, okay, this is going to be a pretty quick rolling train. Is it even crazier than you could have imagined?
Yes, because of the immediate impact, the business value that these AI apps are having, right? Just think about like the way we all work every single day. For me personally, I use the chatbots constantly.
Yeah.
It's like, is this like, I was sort of joking about this thing's smarter than most of my friends, but it is, like, so I turn to it for technical advice, for asking questions, and more I'm using agents to perform routine tasks. Right. And so the business value is so high that we see customers rapidly adopting this stuff much, much, much faster than previous technological evolutions, like the movement from VM-based systems to cloud-based, container-based systems.
Right.
That took a decade. This is going to take, months, not years.
Yeah.
Right. For this transition to AI. And so change is being thrust upon us in the industry.
Absolutely. And you mentioned customers, which we know we're always mostly interested in their user experience and catering to them. Are there particular demands that you're seeing that are kind of shaping how we, formulate our innovative security measures in terms of AI, or just in general with all these new things happening?
Yeah. So there's two things. The first is that basic question about like, where did my data just go and how do I protect it? Right. And so AI defense is designed to specifically answer that question. The next big wave that we see coming in the security zone is with the adoption of agents in the workplace, we need to think differently about access control. And let me describe the problem. So for decades, we've had very clear capabilities that follow the zero trust model around least privileged access.
Right.
So salespeople can get to sales applications and IT people can get to IT applications, but sales doesn't go to IT.
Right.
That's what the least privileged part is. Cisco Secure Access, but also our competitors, Zscaler, Palo Alto, they all have varying levels of capabilities around this that I would describe as mature.
Right.
Now, the other end of the spectrum, you have machine access. So a printer can access the print manager and nothing else. And this is something Cisco does particularly well because the printer is not going to log in and authenticate into a proxy, right? And so we use the network and our identity services engines to identify, hey, this is a printer. We put a tag on that, and then wherever that packet goes, we know it's a printer. But it's very narrow, very rigid access. Now, all of a sudden, we have AI agents, and an AI agent oftentimes has a human credential. So human credentials are very long-lasting, and they're still pretty broad.
Yeah, right.
Even if you're a salesperson and get to sales applications, that could be 100 applications. So you have these agents that have the broad access of a human, but the common sense of a printer. It creates an enormous security problem.
I can imagine.
Right?
Yeah.
Like real world example. I want to use an agent to process my expense reports at Cisco. Right? No one likes doing expense reports. It's cumbersome. It's a pain. So this agent needs to be able to access our travel system, which is Concur, my calendar, my photo roll to look at receipts, and then process transactions on my credit card.
Right.
I want the agent to access my credit card. I do not want the agent to buy a Porsche.
I was gonna say,
right?
not right now anyway.
On my credit card, it'd be a used Porsche. We need to put almost common sense guardrails around that. But you can't hard code that, because if I tell the agent, hey, don't let the agent buy a Porsche, the agent will be like, oh, okay, cool, I'll buy a Ferrari.
Exactly.
Right? Make the problem even worse.
Yeah.
And so we need that same AI-based reasoning to supervise the AI application. So AI, protecting AI, well, that's the world we're living in. It's really the only practical solution.
Right.
And so we're working to put those capabilities into our platform, which is the Cisco Secure Access.
Right.
For user to application interactions. And then with the hybrid mesh firewall, Cisco's firewall, we can intercept application to application or agent to application traffic. So
That's
yeah,
awesome.
it's a bold new world, but these are dramatic shifts in how we do security.
Right. And as you mentioned, you kind of have to go with the flow. You can't just ignore that because you'll be left behind.
No, it's happening with or without us, right?
Yeah.
And so we need to get in front of this and help our customers control this problem.
Absolutely.
Yeah.
Love it.
Yeah.
Love it. I've heard you mention something about the platform effect and its impact on customers. Can you just tell us what that is and why it's important?
Yeah, it's incredibly prevalent in the market. And with this AI transition, the platform philosophy becomes more important than it was even just a few months ago. So the idea behind platform is that a platform is not a bunch of products that you buy from one salesperson.
Okay.
Right? That's what some vendors talk about. But
Right.
a platform is a system of systems. These things work together. And let me be very specific what a platform can do. So I talked about AI defense, right? Which is putting that AI awareness into our network security. So we're taking AI defense and we're making it a feature on our hybrid mesh firewall. We're taking that hybrid mesh firewall and we're making that a feature in our switches and our routers, right? With smart switches. We're taking that intelligent network fabric and we're bringing it right into the GPU complex so that we can do that GPU to GPU communication. That's a platform, right? So these are individual systems that are designed to work together. But here's the best part of it is we're designing this in a way that we can extract telemetry from the inner workings of these AI-based applications and provide that telemetry to Splunk without driving a gigantic ingestion bill.
Got it.
Right? So Splunk becomes this platform that allows us to look at and understand and observe these applications in fine-grained detail. And because we're thinking about this from the beginning, the platform effect at Cisco, I think, is very, very, very interesting to customers.
Would it be correct to call it somewhat of an ecosystem as well, or is it not so much the same?
No, it's a great question because in a platform-based world, there may be some customers that choose some systems that aren't from Cisco. I don't know why they would, but it's like misguided customers. So we have to make this platform open and extensible. So it's going to work with heterogeneous infrastructure because we're Cisco. Most environments we're in have other vendor products in there, and so we interoperate, and that's the ecosystem part of it.
Right.
But very much a true platform is when the whole is greater than the sum of its parts. Yeah.
That makes sense.
Yeah.
And it seems like that would be an advantage to have that be that way.
We believe a significant advantage. Yes.
I know we talked about sort of what's happening with AI and what we're doing at Cisco, and maybe there isn't anything yet, but as you think about the future, are there innovations that you think either are going to happen or you would love to see happen that are just going to change the way we do things even further?
Yeah, I think the next 3 years, so in hardware terms, think 2 major design cycles, there's going to be a whole bunch of innovations. So what's happening with AI infrastructure is this stuff is running so fast that we're starting to reach a point where we can't move electrons over a copper wire fast enough. So we're going to need to go directly from silicon to optics. And this is advantage Cisco. Remember the platform effect we talked about, right?
Yeah.
So we believe that somewhere, like right now we're shipping 800 gigabits per second per port. We just announced 1.6 terabits per second per port. Right behind that will be 3.2 terabits per second per port. Somewhere in that transition, we're going to have to go directly to optical. And so that's going to, again, drive the need for more integrated solutions. The other big thing that we're challenged with is these systems are so powerful and so power hungry that delivering the power to them and then cooling them is a real challenge. And so we're going to start moving into a world where liquid cooling becomes a requirement. I think liquid cooling and integrated optics is going to drive rack-based systems. Like customers are not going to build data centers out of boxes. They're going to consume it by the rack. And this is, I think, a big opportunity for Cisco. And in fact, it's my main focus area running product development is building an integrated solution that includes the network services, the compute, the storage, the security, the load balancing, all of that software-defined, composable, liquid-cooled, optically interconnected, delivered by the rack. It's easier for the customer to consume.
Right.
There's a ton of innovation that has to happen between where we are now and what the world I just described, but that is the path that we're on.
That's interesting. And so just to be clear, when you say by the rack, you're talking about a system that literally includes all of those components within one framework, right?
Exactly right. And so we may be incorporating storage from a third party and into some security technologies from outside vendors, but we integrate that all into a single solution that the customer could. It might even be a single SKU.
Right.
You click here and boom, here's a rack of gear. I know, right? But that's what customers want.
Of course. Yeah.
What company do you think defines themselves by saying we're really good at building data centers? That's not their core business. Their core business is the software that powers their business.
Absolutely.
And the data center is the engine that drives that software. And so we make it easy for these customers to have the latest and greatest engines to power the apps that are going to drive their business.
Right, which really aligns to our goal of simplifying the experience for the customer.
Yes. And when we talk about being the AI infrastructure company, the network, I will argue, is the hardest part in all this. And so that's what gives us I would say permission to play, or maybe even an unfair advantage as we stitch this together on behalf of our customers.
Got it. And hardest part because of the amount of data that just needs to be transferred back and forth, just that amount.
If the network becomes the backplane that you're using to define and create a computer, and it's a coherent system, which means each of the individual processing elements are working in lockstep, then that network requirement is very, very, very demanding. And what's interesting, if you look at like a networking ASIC, those have more gates than a GPU.
Oh, really?
Yeah, the network ASICs are larger, and because I always like to say, in simple terms, the GPUs are unbelievably fast, and the network has to be faster.
Right.
Because we got to feed the GPUs, right? So, so typically networking has been the bottleneck for most of these AI-based applications, and we can address that bottleneck.
That's amazing. If only there were a company that were known for its networking.
The networking company,
yeah. Oh, wait, that's not. Never mind. All right, that's cool. I gotta say, I love how you describe and define, these topics, which are not always easy. I wanted to ask you, have you ever taught professionally, or even thought of it?
Yeah. Yes, I have. So I teach a bunch of classes at Lehigh University, and you could ask me, why do you do that? 'Cause I don't get paid for doing it. I just enjoy doing it. It's fun. And what I really like is I see these kids coming up, and if, I can help play even a small part in getting them to think about technology and Silicon Valley, that's a huge win. And a bunch of those kids are working at Cisco, and they're some of our most productive product development people. I really enjoy that side of the business.
That's so cool. And it's, I come from a long line of teachers, and of course, most teachers will tell you that they learn more from their students. Do you find that to be the case in terms of like your teaching experience and how you bring that to work?
Absolutely. It's first of all, I find it's just really encouraging and uplifting, and there's just a lot of positivity around, sort of imagining what's possible.
Right.
But also, the thing I've learned is we talked about innovation and the imperative for innovation. Where do good ideas come from? They come from everywhere, right? So the more diverse that we can be, the more perspectives that we can embrace, the better our thinking. And a university environment really kind of unlocks that creative thinking, I believe.
Absolutely. Speaking of creative, and we've sort of stepped away now talking about teaching. Let's step even further away from work for a second, although I think it's going to bring it right back around, because you have a really interesting family history where your mom was a concert pianist, dad an engineer, which are two different but very cool professions. How did that impact your decision to get into tech, and then how did that get you where you are now?
Yeah, sure. Yeah. So my mom played with the Boston Symphony, and my dad was an engineer at Raytheon. And it's true. Those are like, in some ways, I used to say mom was a hummingbird and dad was a Labrador. Very, very different personalities. But my mom used to say to me, she used to say, "I want you to love music. I want you to appreciate music, but I forbid you to make it your living." I'm 5 years old, right? So I'm like, okay. So I thought that, I'm just not gonna be a musician. So I'm an engineer, and I love engineering, and I love the tech side of things. But the creative aspect of as we talked about earlier, like thinking about things in a new light, a new perspective, that clearly comes from the art world.
Absolutely.
Right.
Yeah.
And so it's only later in life that I've started to play, and I'm not good, but I play saxophone, and I do it just. I'm never going to have a concert. I'll never play with the Boston Symphony, but I really enjoy, that process and that kind of side of life. Right? Yeah. But the magic is the intersection between those two.
Definitely. Well, as a fellow musician who doesn't play professionally anymore, but I used to do music for a living, it's something that once you do it, it can always stay with you.
Yes, exactly. Right. Yeah. I do it because I love it.
Exactly.
That's the only reason.
And that's the best reason.
Yes. Yeah.
I think that's a great way to bookend the conversation. Tom, thank you so much for spending some time with me today, and I really appreciate it. I hope we can do this again soon.
Yeah, it'd be fun. Thanks for having me.
You got it.
Okay.
Take care.
Thanks.